Very good morning. Today I want to start experiment number 9. Title of experiment is determination of calcium and magnesium hardness of the given water sample by EDTA methods. Okay. Next. Now today's title of the experiments and subject course outcome are prepared here. So those 4 course outcomes are mentioned here. So one is acquire capability to conduct experiments and estimate the concentration of different parameters. This is the first course outcome. Second course outcome is compare the result with standards and discussed based on the purpose of analysis. Third course outcome is determine type of treatment, degree of treatment for water and wastewater. Okay. Next outcome is identify the parameter to be analyzed for the student project work in environmental stream. So these are the course outcomes are prepared. Title of subject is Environmental Engineering Laboratory and the subject code is 18CVL67. This comes in 6th semester of civil engineering departments. Now these are the apparatus or equipments are used to conduct given experiments. So in experiment 1 I have already clearly mentioned names also. Here is also with names is given, but just you read out, but don't forget all these apparatus and equipments names. Okay, these are the continuous we are used in different experiments required to conduct. Next, concept of this experiments, that is theory. The presence of calcium in water supplies results from passage through or over deposits of limestone, dolomite, gypsum and gypsiferous shale. The calcium content may range from 0 to several hundreds milligrams per liter depending on the source and treatment of the water. Small concentration of calcium carbonate combat corrosion of metal pipes by laying down a protective coatings. Appreciable calcium salts on the other hand precipitate on heating to form harmful scale in boiler, pipes and cooking utensils. Magnesium ranks 8th among the elements in order of abundance and is a common constituent of natural water. Important contributor to the hardness of water, magnesium salts break down when heated, forming scale in boilers. Concentrations greater than 125 milligram per liter also can have a cathartic and diuretic effects. Chemical softening, reverse osmosis, electrodialysis or ion exchange reduces the magnesium and associate hardness to acceptable levels. The magnesium concentrations may vary from 0 to several hundreds milligrams per liter depending on the source and treatment of the waters. So now see principles of these experiments. When indicator is added to hard water, the calcium and magnesium ions form a complex of wine red color with erythrum black tea at pH of 10 plus or minus 1. EDTA has got stronger affinity towards calcium and magnesium, and thereby by addition of EDTA the former complex is broken down and a new, more stable complex of blue color is formed. This is the principle of these experiments. Apparatus. Which are the apparatus are used to conduct these experiments? Burettes, pipettes, conical flask, volumetric flask, beakers, spoons, glass rods, weighing balance, dropper, etc. So these apparatus are used to conduct these experiments. Reagents. What are the reagents are used for this experiment? EDTA reagent is used, that is 0.01 molarity. How to prepare this reagent? Dilute 3.723 gram of EDTA salt and dilute to 1000 ml double distilled waters. Okay, so now we are ready to get EDTA of 0.01 molarity by this step. Next reagent is sodium hydroxides. We are used sodium hydroxides reagents of 1 normality. To prepare this sodium hydroxides, dissolve 40 gram of sodium hydroxide in distilled water and dilute to 1 liter double distilled water. Now we are getting sodium hydroxide of 1 normality. Second reagent is Murex indicators is used. Murex indicator is used. Next, procedure. How this experiment is conducted. Now see the steps how this experiment is conducted. Procedure. Take 50 ml sample in a conical flask. Add 2 ml sodium hydroxide. Then add pinch of Murex indicators. Then pink color appears. After adding Murex indicator, pink color appears. Titrate the sample with EDTA of 0.01 molarity till the color changes to purple. Note down the burette reading. Now calculate calcium and magnesium using the given formula. Okay, so like you repeat 3 trials according to these steps and calculate calcium and magnesium of the given sample by using formula. So these are the observations and tabular columns. So in observation you write in burette EDTA solution of 0.01 molarity, and in conical flask 50 ml of sample, that is tap water, plus 2 ml sodium hydroxides plus pinch of Murex indicator. So these are there in conical flask. Now which indicator is used? So indicator used here Murexides and end points. So color changes pink to purple. So this is the end point in observation CY. Next, tabulations, tabular column. So in first column, sample, that is ml of sample is written in 3 trials. You enter burette readings. So in burette reading there are 3 columns. One is IR, second one is FR, next is difference. So different we are getting FR minus IR readings in ml. Now do the average of 3 trials. So we are getting difference, that is in ml of EDTA added. Okay. So this is the tabulations, how to enter the readings. Next, calculation. Calcium in milligram per liter is calculated by using this formula, that is ml of EDTA added divided by ml of sample taken into 400.8 milligram per liter of calcium carbonate. So we are getting in milligram per liter calcium. Now calcium hardness is given by the equation Ca into 2.49 times. So now we are getting milligram per liter. After getting the calcium, now you multiply 2.497, we are getting calcium hardness in milligram per liter. So then now you calculate total hardness equal, we know the equation, total hardness equal to calcium hardness plus magnesium hardness, that is the total hardness. So therefore magnesium hardness equal to total hardness minus calcium hardness. Now substitute the value in this relation, we are getting magnesium hardness in milligram per liter. Now you calculate magnesium in milligram per liter. So that is magnesium hardness into 0.244, you multiply. Now we are getting magnesium in milligram per liter. Now based on these calculations, you write comments. So here see these comments. The total hardness of given sample of water is this much milligram per liter, but according to the Indian standards for drinking water, permissible limit is 300 milligram per liter. Excessive limit is 600 milligram per liter. Therefore, the sample of water is calcium hardness and magnesium hardness is this much milligram per liter and this much milligram per liter with respect to calcium and magnesium hardness. So this is the comments based on the results is written. So these are the references are referred for these experiments to study these subjects to cover in detail of these experiments. Thank you one and all. Next experiment I will continue in next class.